Alright, welcome back everyone. In this video we're going to be talking about numbers and the sets that they fit into. First off, I want to talk about what a number is. And a number is pretty much a concept. You can't imagine a number. Sure, you can imagine 5 bananas or 5 anything, or even the number 5. But you can't imagine the fiveness of it. It's a concept. Next, I want to talk about our number sets, and these are the sets that numbers fit into. This is a web of how they fit together, you could say. I'll just start here. So we have our natural numbers, or sometimes they're called our counting numbers. And they're named so because when mankind first started, they counted their bananas or whatever. And they counted 1, 2, 3, 4, and so on. And that's why they're called the natural numbers, and they fit here in the web. And then they came up with, well, what if I had nothing? You know? So they came up with 0. And those numbers are called the whole numbers. 0, 1, 2, 3, and so forth. So they have our natural numbers, which are here, plus our 0. So they have, in essence, 0 as our whole number, plus all the natural numbers, right? Moving on. Integers. Then they came up with, well, what if I have less than 0? What if I owe some, right? What if I borrowed some? Then we came up with our negative numbers, and they fit here. -3, and so forth. -3, -2, -4, -5. Our whole number, and our natural numbers. I want to make it clear that integers can be whole numbers and natural numbers, right? Because they fit inside this area. So, in essence, the number 2, the number 3 is natural number, a whole number, and an integer. Okay, just want to make that clear. Rational numbers. Rational numbers is a number that can be written as a fraction with 2 integers. Like the number 1/3. It can be written as 1/3 or 0.33333. And 3/5, which can be written as 3/5 or 0.6. So our integer here is 1 and 3, 1 and 3, 3 and 5, 3 and 5. Because we're writing it as a fraction, and we can take any integer, right, and write it over 1, then we'll get the same number back. And so our natural numbers, our whole numbers, and our integers are as well rational numbers, as we can see here. Because our rational numbers cover all the integers, whole numbers, and natural numbers. Irrational numbers. Irrational numbers are numbers that are not exactly defined by a ratio or a fraction, like pi. Pi comes from when you have a circle and you have your diameter, right? Your diameter. When you take the diameter and the circumference, which is all the way around the circle, you take your circumference, divide by the diameter, you'll get 3.14, and so on. These numbers here don't repeat as this number here does, which is 0.33333. That's what this line right here means. It means it repeats. But 3.14 does not repeat. It goes like 2, 7, 6, 5, 2, 9. I'm making these numbers up, but you get the gist. And as well with E. E is like 2 point something something something. That doesn't repeat. As well with square root of 2. Let me look that up for you. Square root of 2 is 1.41421356, and so on. You can see it doesn't repeat. As well with square root of 10. And these numbers are itself over here by themselves the integers. I mean the irrational numbers. Yeah, they're by themselves over here. They don't intermingle with these, right? These numbers from here up are called the real numbers. Sorry about that. And they're the real numbers because unfortunately in math we have our imaginary numbers. Which is pretty much the square root of a negative number, -1, right? I squared equals -1. I'll go more into depth about imaginary numbers later on in videos. I don't really want you worrying about that right now, getting confused. And they belong in this big family called complex numbers. A complex number can be like 6 plus 2i. That's a complex number. But I don't want you worrying about that and getting confused.